All right, so it should be recording and should be showing your screen. I don't see the slides just yet, though.
Wait, can you see it?
Not just yet. Maybe I need to do something here. Oh, there we are. It was there for a second, and then it switched back to showing the sharing screen. Let me see if there's a way to get this off. Oh, there we are. Did that do it? Try sharing yours again. I think I killed your share somehow.
Who, me?
Yeah. Are you sharing the desktop?
Hold on. I'm going to do a share.
Wait, I think I got it. There you are. Now we can see your slides. It's good. All right, good. And now other people can see it. We're in the road, on road. Okay, go ahead.
Wait a minute. Can you hold on just to make sure? Can you see the second slide, third slide? Can you see the flipping?
Yeah, it's working.
All right. Hello. So I can begin?
Yeah,
hello? All right. So hello, everyone.
Hey there.
Hey. So I'm Ming. I'm from Tufts University, Department of Computer Science. And Sam and I have gone, we've gone back, well, quite a few years now, like, you know, for a good number of years in this decade. And Sam asked me to do a presentation on security responsibilities, citizenship, something along that line. So I have, before I begin, I have a question to ask everyone. Like, what do you hope to all learn from this course, including Sam as well, too, the one that you're currently teaching? Like, what are you currently hoping that everyone gain? I want to start off with that question first.
Well, I'm just, yeah, go ahead. Caitlin, what do you got?
To no longer be baffled by the administration.
Did you hear that? She said to be no longer baffled by the administration.
Yes.
And that's my idea, was to sort of like the CISSP, that people would understand what it is to hold a position of responsibility and why they, and how they can protect the people under them and how that looks from both sides. And so yeah, go ahead.
Got it. Because one thing I was noticing, which was very interesting, was the way you started off the class when you showed all those news items there, no matter whether it's good or bad. So that got my mind thinking. I was like, I think I'm getting the gist and the idea of what the course that you're teaching is about. And it's interesting because what you did for the first 10 minutes of the class is something that I'm actually going to mention in this talk that I have. So I hope that this talk will be at most 30 minutes, because I don't want to bore people to death. I think it's important to answer any questions that you have. So how I'm going to structure this presentation is the following. I'm sure people ask, like, what in the world does the word citizenship mean? Like, in what context? What does it even mean to be a good citizen? And especially why is it important now, especially in this day and age, and in this field of cyber, and especially in cybersecurity. I will show a long dossier of evidence and pictures and screenshots. Some of the stuff that you may have seen in somehow before on why responsibility and citizenship is so much more important now than ever. And I will mention one last thing is being a good citizen, understanding the problems that are out there, actually can present opportunities for everyone, in which everyone wins. And I will talk to you what we did at Tufts, knowing the problems that are out there, not only within Tufts, but globally as well. Okay, so that's going to be the structure of my presentation. So I want to take a step back. So why am I here, and what got me here, which was what got me into security, what got me into cybersecurity? So I got my undergraduate degree in 2002 in computer science. And like every computer science graduate, you know, after you finish 4 years, everyone would want to build software. You want to make video games, all the cool stuff. I mean, I see it even all the time now with our undergrads at Tufts. You know, it's most people think that, oh, it's a computer science degree. The only thing I can do is software. So the what they call a stereotypical path is to go to Google, Microsoft, Facebook, Apple, Microsoft, one of those shops. That's generally the stereotype. And I was no different, I would say. I mean, in 2002, we didn't have that many opportunities, but still, that was a mindset. Everyone goes to work on software. So in the 2004 Usenix annual conference, Usenix is a professional organization on systems. It's way up there with the ACM. They had their annual conference in Boston, Massachusetts. And I got sent through work. They were kind enough to pay for me to go to the annual conference and to sit in on panels and also to take 2 tutorials. And the 2 tutorials I went to had to do with security. One of them was on network security, and the other one was with secure software development. And the instructor of the secure software development course was Gary McGraw, Dr. Gary McGraw, who's considered one of the founding fathers of software security. And, you know, he sold me into this idea that cybersecurity is a career path. And in fact, what really hit the home run, what really resonated from that conference was when I sat in their panel to talk about when they talked about the politicalization of security, from Ed's work at Princeton University breaking DRM, to Gary's work, reverse engineering software. And it came to they brought this message, which was, be a good citizen. We have dug ourselves into a deep hole. People have absolutely, especially lawmakers, are absolutely clueless when it comes to cybersecurity and on technology. And we need technologists to step up to the plate and inform those who really need it. And I did a synopsis of a couple of talks at that presentation, which is still available on the Usenix website. And that's the screenshot, a snippet of the synopsis of the panel, which really convinced me, set me up for a career in cybersecurity. And to remember, this was 2004. 2004, that was 15 years ago. And here we are 15 years later, and we're facing the same problems. Not a whole heck of a lot has changed. But before I get into the dossier, what does it mean to be a good citizen? What did Gary and Ed say are some qualities of being a good citizen? And they mention a few items, such as being more involved, especially when it comes to civic engagement. Be nonpartisan. Because right now, in 2004, I remember Gary and Ed were saying, it's very hard to sit at the same dinner table with the political parties. No one can sit at the same dinner table together and talk things out. Talk to those who are curious. Be open and encourage debates, constructive debates. I'll give you another example, rights to repair. The idea whether you should fix your own stuff like the iPhone or your computer, because there are some people who don't believe that. Tell the truth and convince people what's really going on. Show and prove. And so I remember Gary and Ed said something along the lines of, this is why things like reverse engineering is so important, and that banning and outlawing reverse engineering make no sense at all. So here we are 15 years later. 15 years later, after I've come to, after that 2004 Usenix conference in Boston. And so what had happened since? Well, not a whole heck of a lot. We're still in a deep hole. If not, we're in a bigger hole. And now we've gotten to a point where cybersecurity and technology are not only national issue, but also international. Old techniques are still very successful. How's SQL injection doing these days? How's password cracking? Still an issue. Companies are still throwing monies at the problem. If you still don't believe it, there are many software developers, and we see this every day, that still don't know anything about cybersecurity. Things are going more complex. Things like we have phones, mobile devices. That was a big thing 5 years ago, but now we're having AI, ML, blockchain, bots. The whole list goes on. Disenfranchisement of women. Computer science has huge problem when it comes to harassment. Cybersecurity, the numbers of women participating in cybersecurity for a career path, numbers are really low. Communication between security and business folks, not understanding trade-off, still a problem. And educating federal and governments, local, still they're not asking the hard question. Still, we're facing the same exact problem we are 15, 20 years, decades ago. Everyone with me?
Yep.
So far, so good?
Yep.
Okay. So the next bunch of slides, I'm going to go through pretty quickly that gives you evidence that support these list of items. 15 years later, we're still in a deep hole. We still have so many problems that are unsolved, that we are still fighting 15, 20 decades later. A ghostly of sobering reality. So I'll only try to say a few words about each and every one of these slides. Josh Abraham, Praetorian Cybersecurity, based on many pen test engagements. What are the biggest problems? Stolen credentials, passwords, still up to this day. 2013 to 2016, these were the data. Dropbox, password reuse, 60 million credentials lost. NSA, Rob Joyce said in his presentation, how do we get the actors? What do we do to break into systems? Passwords, weak password, hard-coded passwords, legacy protocols. Okay. Here we go. Default passwords, very, very common. Also very well known. Who common in the Internet of Things? We're talking about like webcams. Whole list of even a toaster, laundry machine. There you go, from Veracode. Developers are still not trained in secure coding. Even up to this day, what are some of the biggest issues that are found? Cross-site scripting, SQL injection, cryptographic problems. Still a problem even up to this day, 2000 as of recent. Very recent. Plain text passwords stored by utilities. One of my favorite articles from Kelly Jackson Higgins. Still, most computer science programs, cybersecurity, forget about not even taught as a core, not even mentioned in the curriculum. Things are getting more complex. I mean, the story I tell students, Windows 3.1, 500 million lines of code, something like that, in the hundreds of million. Now when we're talking about the latest Mac OS Windows, we're talking about tens of millions of lines of code. More lines of code, more bugs. You can't keep an eye on all those lines of code. Security conferences, especially the ones that Sam and we go to, there's a lot of emphasis on breaking stuff. And now, I think the biggest change in the last couple of years, lots of policymakers, lots of lawmakers are now going to them. I even crashed a party of lawmakers. That was connecting lawmakers and the researchers. Look, most of the attacks, well-known techniques. Ransomware, what's the starting point? A lot of the time, phishing. A lot of stuff that we've known before. Okay, a lot of these issues there are patches out for. Yet we haven't solved those. Here's some numbers on the cybersecurity workforce problem, especially when it comes to women. This is from Deidre Diamond, 2016. 10% of the cybersecurity workforce is women. 1% of the cybersecurity is women leaders. 53% of the women end up leaving industry. Jeremiah Grossman, how much money did you spend on those cybersecurity products? That's not in a million, that's in the billions of dollars. And this was very recent. This was just a couple of months ago, early this year. You spend all that money, and guess what happened? You still get breached. So what's the point? That's one of my favorites. Still a problem. So, look, some of the most common problems that we still face up to this day, very difficult to solve, and they've been outstanding. Things like phishing, social engineering, password reuse, attribution, writing secure code. But also this point, communicating and connecting with non-technical folks, the policymakers. We live with a lot of those people too. I mean, it could be our parents, it could be our grandparents, it could be our siblings. Okay, this is still such a hard problem. Why is policy important? Look, policy and legislation plays a heavy hand. Plays a heavy hand when government and lawmakers make rules, make laws, because technologists and companies can't do it, or they don't want to do anything. So the senators and Congress and lawmakers step in. For example, in this case, is to have Internet of Things be patchable. Sometimes what lawmakers introduce make no sense. Case in point, Australia. They want to ban encryption in some way. Is that correct, Sam? You heard that, right?
Yeah, I heard about that. Yeah, it's just like everybody. They don't want any end-to-end encryption. They want to have the keys for everything, like the United Arab Emirates.
And the great thing about that conversation is, this is like the nth time, the many time that we've had this conversation. In fact, back in the days, the Clipper chip. We had Clipper chip 1 and then we had Clipper chip 2 from the NSA. This has been a debate that's been going on for decades. And yet, people still want to ban mathematics. Okay?
Yeah.
So this was a slide I liked from Matt Blaze and Sandy Clark from Hope in 2016. We have a lot of engineering and application issues, but some of those are pretty easy and moderately difficult to resolve. The biggest problem when it comes to are the policy issues, okay? Because it's really hard, especially if you have lawmakers and policymakers that just don't know. They're not up to speed on different technologies and even the basics, okay? So knowing this problem, knowing that, okay, we have a literacy problem, we have an education problem, we have the haves and have-nots, especially when it comes to knowledge, okay? We also have people who are very interested on the other side in this matter known as cybersecurity, and they want to learn more. I'm talking about the non-technical people. So what do we do? What can we do about this? I remember before 2015, I was getting emails from other colleagues in other departments saying, they want to work with us on cybersecurity because we know that this is an up-and-coming issue. So it gets to a point when you receive one request, okay, whatever. But when you receive many different requests for over a period of time, there's a pattern. That there is a demand for this knowledge. And so the real day when it all said and when it got made, one day that made the biggest difference was November 1st of 2015. There was an invited guest speaker, Eli Khan, who was one of the high ups. He was way up. He was the vice president of Squirrel, which is now part of Amazon. And he's a friend of ours for a long time. And he was giving a talk to a friend, to another colleague at the political science department on I think it was the day before. And I didn't know Jeff Taliaferro before that guest speaker event in Pisa. We shook hands, and then I had to head back to do office hours. But I remember like an hour after the talk, Jeff sent me an email. You know, he said, Ming, it was nice to meet you briefly. I have this idea. You know, my area of expertise, Jeff's area of expertise is international security. We're wondering if you and I can combine knowledge and our expertise to offer something in cybersecurity and cyber warfare. We can offer something joint at Tufts. And this was the one time I will never forget my immediate answer. My immediate response to that was, absolutely. Hands down, yes. We're going to go through this work. We're going to go through this process, and we're going to offer up a course. We're going to offer up a course on cybersecurity and cyber warfare. So we started planning for the course in 2016. The inaugural semester was in 2017. We had like 40 students. 40 students, very important. It was 20 engineering and 20 non-engineering arts and science students. Arts and science departments also are the like non-computer science department. They include political science, international relations, English, economics, you name it. So we had a good mix of tech and non-tech students in the class. There were a few, like 4 students that were that had both technical and the political science knowledge, which was a very rare number at that time. And so we ran the course in spring 2017 the first time, and we felt that, generally speaking, it went very well. We offered another version of the course in spring 2019, which was this past semester. So you may be wondering, if you want to do some background reading on, is this something that is needed out there? And the answer is absolutely. Michael Schumacher, who used to be at the Brickman Center, he used to head cyber policy over there. He asked about designing a course on cybersecurity for law students. Bobby Chesney, who's at the University of Texas Law School, also offering a course on cyber law, cybersecurity law and policy. Okay, so there are related works out there. There is a demand for such knowledge. That is not just a technology. You know, learning just how to fire up Metasploit or John the Ripper is not enough. Because now the real problem is, you know, the real people in power who's in charge, the policymakers, CISOs, CEOs. Those are the more important people that need buy-in from, that we need to convince. So how does this course fit at Tufts? Well, the nice thing about this course on cybersecurity and cyber warfare is it fits the DNA of Tufts University. Tufts is very famous for medical programs, the medical programs, and also international relations. We have a Center for Active Citizenship. We have the Fletcher School of Law and Diplomacy. We have a very strong international relations undergraduate program. At that time, the dean of the Fletcher School of Law and Diplomacy was James Stavridis, former retired admiral of the U.S. Navy. And when he was dean, they put out a strategic plan called the Know the World, and they identified specifically cybersecurity and cyber warfare as potential growth areas for faculty and research and teaching. In relation, School of Engineering. You know, we, on our strategic plan, is to educate engineers on innovative and ethical and societal needs, okay? But more, one thing that ties everything in is leadership. You know, this is an opportunity for Tufts to not only bridge multiple departments together, talking to each other. One of the problems if you work in higher education is and this hasn't changed, and it's going to be very hard to change, is silo. People in departments like to work in their own little corner. And when we are now in an age where lots of things like cybersecurity, data science, they're all interdisciplinary. And so the whole idea of just locking yourself into a closet or into an office or to another building doesn't work. So this was an opportunity to break that mold and to provide leadership. So our course mission was, look, this is the reason why we're still facing. We will believe, we believe everything that I said earlier. You know, a lot of problems in cybersecurity is due to technical and non-technical communities and the gap. And so what we want to do is we want to build the bridges. We want to connect students, faculty, to understand cybersecurity, but also to talk. Just get the people to get all from different aisles that just keep talking. Our educational goals for political science and international relations to non-technical students expose them to the technical aspects of cybersecurity. That also includes like password cracking using Kali Linux, the resources and tools that are out there. Computer science students is to expose them to policymaking and strategic management of cybersecurity. This also includes a lot of writing. Okay. One thing that we did not do in 2017 course, but we did in the 2019 course, was to have a big class debate on one single topic. That was really good in 2019, so we debated on GDPR. So just to show you like the tangibles at the course, we did. For students, the whole class played a capture the flag game. The capture the flag game in this course, it was a vulnerable, unpatched, never been patched Windows 2008 server with Hack Me Casino. And so students had to find vulnerabilities. There was no number of vulnerabilities that teams had to find, but the most important thing was the write-up. Teams were mixed with, we tried to create teams with 2 male, 2 female students, two non-technical students, and 2 technical students. But what was really cool was the TA, the teaching assistant, and my partner in crime and friend, Matt Weinberg, he said, you know what, why not in this capture the flag write-up, we have, each write-up must have one section that said, for all the vulnerabilities that were found on the system, tie them in and relate them to previous vulnerabilities that were found. I'll give you an example. One team connected SQL injection to the Mossack Fonseca, the Panama Papers crisis. Okay. Student had to write policy memos. Student had to write policy memos, 2 pages max, directed to someone at the senior policy or C-suite level. One person wrote a memo to Alex Stamos when he was still at Facebook. And in fact, I shared that memo with Alex. And he had some really, really long feedback. And actually, he was kind enough to provide a lot of feedback on that paper. He said it was a very good exercise for the students to do. Now, Alex, of course, is at Stanford. Okay. One of the things that I have a big dissatisfaction on higher education is we want to have students take their responsibility for their own learning. What I mean by that is too many students go to college and they expect, okay, you give them the instruction. You give them the specification, which is like 3, 4, 5, 6, 7 pages long. I'm sorry, but you know, in the real world, sometimes you'll be lucky enough to even get a sentence on your task or your project to do. And so what it really boils down to is open-ended projects. And sadly, I don't see this too often in higher education is, you know, students, you know, especially in cybersecurity, there's way much more to learn on your own, like building labs, building like a network lab that people got to take advantage of. That's how most of us, and I'm sure Sam, you as well, that's how you learned a lot of the stuff that you're teaching right now in security. You learned it on your own. Is that correct?
Yeah, of course. Yeah, you have to.
Okay. So we incorporated this into the class, and that teams and students, they could do whatever they want. You know, it's something to engage with the cybersecurity community in some way or capacity. I don't care. We didn't care if it was going to the Berkman Klein Center at Harvard to go to a talk, or even to meet with practitioners at local companies, or even to go meet at a conference or a startup, things like B-Side Boston or local security meetups. Those experiences are the ones that last a long time. I mean, that's a skill that, professionals will need down the road. Okay. Those are things that are much more memorable than just a damn, quiz or the paper or the project that was just for a class only. So some lessons learned from this course that we taught the first time around: there's a lot of vocabulary. There's a lot of word that people have debates and arguments on. For some perfect example is cyber. The policymakers love that word. But the problem is anytime you mention the word cyber to the technical people, they scoff at it. Especially if you're an older student, you would think that cyber is one of the really bad terms from the 90s, the dot-com days. One of the things that was really shocking to us was the technical, for the non-technical students, the international relation and a political science student, they wanted more technical content. We were really surprised by that. They were all surprised that tools and techniques, they were all publicly available and open source. Okay. And so a number of the students who were on the non-technical side of things ended up taking my security course or my web development course the next 2 semesters. Very surprising. And the best invite speakers students can relate to. I think a lot of students found 1 or 2 speakers that we had to be really effective, and especially that a lot of people were really surprised that, how they got into security. They didn't learn it in the classroom. There are many ways to do cybersecurity, to be in cybersecurity. You don't need to be a computer science just to be a computer science student. You don't need to go to a 4-year university to do this stuff. Many, many different ways to get involved. So what's next? The course, Cybersecurity and Cyber Warfare, will be taught from now on each spring semester. We are also offering courses very related to that are on the same boat. It started off something really special. We're going to offer 3 courses: Computer Science for Future Presidents, which we're currently running, How Systems Work, and How Systems Fail. These courses, we're not trying to convince to people. We don't want to have, we don't want to bring people into computer science. I mean, we don't want to train everyone to be a computer scientist. That's what I'm trying to say. That's not what we're not trying to do that. I mean, first of all, our computer science department and the number of students that we have is just in nosebleed territory right now, and everyone is tired. But literacy is something that everyone needs now. Technically, whether you do want to do computer science for a living or whether you
I think we lost your audio.
That's going to be in fall 2020.
It just came back. Okay. We lost your audio for a minute there.
Yeah. This program was just announced, but we're going to use this program. We're going to use those courses that we have as part of this master's program. Okay. So we're going to do something really special here. And this is something that a lot of schools don't have. The real problem is public policy, as we mentioned. Okay. So the conclusion, if there's anything that you're going to take away from this talk, number 1, technical skills, not everything. Engineering, not everything. Cybersecurity, a lot of it, writing, communication, people relationships. Those things are important. Okay, firing and learning how to fire up Metasploit, Wireshark, they're good. It's nice, but don't think you're the second coming of God if you know those skills. Lots of things that when I got started in security, when I was convinced by Gary McGraw and Ed Felton in 2004 that security was a field, a lot of the problems that they mentioned that I learned then, still big problems now. We're still in a deep hole. I would like to say that there is in a lot of ways, the future doesn't look very bright because we're still having all these problems. But as I mentioned, there are opportunities out there. You can make yes, the problems are bad, but you can actually make things less worse by talking to others, talking to people outside your field and expertise, informing others. That's where the good citizen comes to play. Okay. And I'm sure each and every one of us have people that come and talk to us about what they want to learn more. Definitely go and talk to people. And that's what we mean by good citizenship. You don't have to do you don't have to do a lot, but just talking to other people makes a big difference. And that's all I have. So want to give a lot of acknowledgement. Matt Weinberg, my partner in crime, who's now he's now a vice president at a very well-known financial firm. Jeff Taliaferro, my colleague at Political Science. Winona Sombre, Eli Kahn, Seth Milstein, Cade Crockford of the ACLU. They've all been guest speakers in our cybersecurity and cyber warfare course. And the many, many former students in my technical security course and cybersecurity and cyber warfare. And that's that.
Okay.
45 minutes. Any questions?
Yeah, let's see. Anyone out there? Let me see if there's anything online. No, nothing here.
I see mute your mic.
Yeah, well, they can send in chats. And I'm not seeing any questions pop up, however.
Do you have any questions?
Well, I'm interested to watch this. I think so. Yeah, go ahead. Yeah, what's up?
I want to ask them.
Change your mind.
Yeah, change my mind.
You're shy. All right. Yeah.
With regards to the importance of not necessarily being technically savvy and still having an opening in this career field, I'm actually glad you kind of touched on that.
Sam, would you be so kind to reiterate the question, repeat the question?
You wanted to hear more about how important non-technical people are, is that it?
Yeah, sure.
Yeah, okay. Well, I think that is, of course, the situation. So so can you tell us more about that? Why are non-technical people important here?
Well, how many people are in the cybersecurity field? How many people are in technology or working in technology? I mean, what's the percentage of people who are, it's if you actually think about the number of people who work in information security or even in technical, the numbers are not that large. It's a very specialized environment, I think about this all the time is that, there's, a lot of us, especially if you're in tech, you make good money, especially if you're in San Francisco. But that's a very, very low minority.
Thank you.
Yeah, you had one, Steve. Yeah.
Yeah, with the relatively recent, within a few years, large scale.
You come up here, you can hear you. You don't have to go through me.
Wait, what was the question?
He's coming closer.
With the relatively recent, and I mean recent in terms of years, very large scale, war type actions and positioning for war in the future. How do you think that's changing the overall field of cybersecurity? We used to be worried about just a bunch of passwords being stolen or credit card numbers or, somebody crashing a network. And now, so much more seems to be at stake and people seem to not be really worried about it too much. And how is that affecting the field and the training and how they recruit students? And yeah.
Well, hold on for a second. I want to find this article. It was from this past. I think I got it from my department chair this past weekend, and the NSA is in. They are really concerned. They are really, really concerned. I'm going to try to find the article. Hold on. I'm trying to find it. And look, you mentioned the usual suspect of stuff that, here it is, digital revolution. This was mind-boggling. Hey, yeah, can you hear me? Yeah, Sam?
Hey, I can hear you, but we can't see it. Can you share your screen?
Yep.
There it goes. But it's just showing black. Maybe I'm in the wrong window.
I just shared my screen.
Well, it just shows a message. Now it came up. Good. Okay. We can see it now.
This was from the New York Times very recently. Technology is about to upend our entire national security infrastructure. This was deep. It doesn't mention, it mentions cybersecurity in some capacity, but it also mentions things such as, forget about cybersecurity, forget that. But what about things like quantum computing? What about artificial intelligence, AI? It's the problem now is not just the problem of security. That's the problem. It's this. It said it right here. It's the unprecedented scale and the pace of technological change. And certainly we're talking about the governments, but we're talking, who asked that previous question about like the regular people?
Yeah.
That previous student, I don't know who it was, Sam, hello?
Yeah.
That previous student asked about why is it important, why do we even need to care about the normal human being? This is the problem. It's the scale and the pace of technological change. That's number one. The other problem is the sheer amount of brand new technologies that we have to keep up with. I mean, they already have enough problem to deal with cell phones and the internet and encryption. Look at that. Society have set the norms and rules. What about this? Facial recognition. All right. In this country, it's, we have issues against it. In China, this is already full blown. You don't even need to carry money or a credit card anymore in China, apparently. They just need you to scan your face and there you go, you pay with your face.
Yep.
I mean, it goes much deeper. It's a very, we talk about autonomous weapons.
Yep. Oh, yeah, several questions. You see them in the chat room?
No, not yet. Hold on.
Yeah.
So it's not just security is the problem, but now it may even be a bigger problem down the road. I mean, there's just way too much. I mean, I can't even list them all. I mean, this article just goes on and just say like sensors, firewall, Internet of Things. It's just way too pervasive. It's just too much. It's a complexity problem, and we can't even keep up. There's just a whole bunch of things that we haven't even kept up with. I hope that shed some insight. Yeah, I got a couple of questions here. most people are unaware or don't care about cybersecurity. How do you think we can get more people to pay attention to cybersecurity? This is something that the problem I feel about why people are unaware, don't care about cybersecurity, is because it's just badly taught in K to 12. I mean, can I ask every one of you, how many of you, when you were in K to 12, heard of this thing called cybersecurity?
Do I see one?
Out of
Out
how
of
many?
20.
Out of how many?
Out of about 20.
So even today, earlier today, and I want to thank Sam for this. I mentioned something about the Pico CTF, which Carnegie Mellon has, and Carnegie Mellon hosts the Pico CTF for high school and middle school students, specifically for the reason of literacy, because they know that most of the people, most schools don't even mention that at all. Or how about one of our colleagues, someone that we know in the information security field, Jason Haddink, who he runs Bug Crowd, and so I think he said something on Twitter today that the lunch lady yelled at her daughter and said she's a criminal for bringing a lockpicking kit.
Yeah.
Hello? No, I mean, that is that related to cybersecurity? Of course it is.
Yeah.
Okay. So how do we get people to get more into pay attention? Start young. Start young.
Yeah.
I mean, if you wanna get the real problem is, forget about security. Most of the people at Tufts, they've never even done computer programming until they went to until their first year at Tufts. That's still a problem.
Yeah.
So you want to get people involved, you want to get people to pay attention, especially if people have kids, start young. So that's why I appreciate people like the Carnegie Mellon when they offer Pico CTF, or the Girl Scout. Now they have badges.
Yeah. And Teen Vogue too. Teen Vogue is big on cybersecurity.
Yeah, and they're doing a hell of a lot more than a lot of schools are, which is amazing.
Yeah.
What year was that for the Girl Scouts?
The last 2-3 years I've seen it.
Yeah, it was very recent. It was very, very recent.
They're teaching them lockpicking.
Well, you have to change the policy. If you're for the K through 12, you can't just say we want math and English. So we'll give you an alternative of either computer science or cybersecurity as an alternative to math and English, because all they're expecting is math and English. And sports, that's it.
All right.
Right?
So in your experience with cybersecurity, what is the one thing you have taken away which you feel you would like to apply to the modern world today? Trade-offs. One thing I've learned, I'll give you a micro example and I'll give you a global example. So you use Canvas for submission or homework. So I'll tell you a story from the first lab that we did. So the first lab that I did in my security class, out of all places in the world, it was online submission only. You can't upload. Actually, you could upload, but you can only upload a couple of things. I only allowed you to upload either .txt text file, PDF, or Microsoft Word. Turns out I forgot something. I forgot that one of the lab problems, actually you needed to take a screenshot of a picture of a screen to see how far you went in a training game. So I totally forgot that. So students were complaining initially. Some students were complaining about they couldn't submit online pictures. That was totally my fault. But what ended up happening was students found other ways to post pictures onto their document, onto their submission to Canvas, which was, they use Imager, they use Dropbox, they use social media. We didn't care. In the end, students did. But what happened is, if you lock down things too much, it can cause problems. Sometimes locking things down too much, not a good idea. It actually has a usable problem as well. More glaring example from a global perspective, You know, you can't close, you can't shut down an airport. If you want to secure an airport, the worst thing you can do is shut it down. Because look, it kills the economy. Security is very hard, but there gotta be a good amount of trade-offs around. Another example, CCSF, like emails, like some institutions, I'm not gonna name the institution that did this, but this institution, a very big one of the biggest state schools in the country, their IT department, their security team decided, you know, for every email, you know, to make sure that for phishing, you mark every email as that comes within the school, within the institution, as internal. Every other email is marked like outside, external. The problem with that was they canceled that. They did that for 1 week, and it broke a lot of people's processes, including people who actually were using email subject lines, who need the right program that depended on the email subject line. So after 1 week, it didn't work. Trade-offs. Any other questions? Is the Tufts program also online? We've gotten 50 that question pops up over and over and over again. The answer is stay tuned. As of right now, no, except for like 2 courses. One of them is my online security course, 116, which is a lot of fun. But that's a big problem now.
Do you need a bachelor's degree or can you get certification and work experience just to put you?
Okay, here's a related question. He asks if you need a bachelor's degree to get in that program, or can you get in with things like work experience and certifications?
Oh boy, sites.tufts.edu. Oh, that is a great question. So let me read off this thing for you. Hold on. Let me just go to my. Can you see my screen?
Yeah, it's good.
All right. So you need a resume.
Yeah.
Application. You don't need GRE, which is good.
Mm-hmm.
It said transcripts, but I'm not sure what that means.
Yeah.
The answer to your question, Director, you need a bachelor's degree.
Well, just not to your program, just not forget it. It's okay.
You mean to work in the field?
Yeah.
Oh, you're just talking about to work in cybersecurity, not necessarily to enter your program.
Oh, God. Oh, that question. So, do you need well, here's the thing. I got a computer science degree, and I didn't learn a damn thing about security.
Yep.
This was 2002 to 1998 to 2002. You know Peter Zatko, Mudge?
Yep. Yeah.
Mudge. You know what his degree was in? Music, at the Berklee College of Music in Boston.
Yeah.
I can tell you a lot of people that we know in the field don't even have a college degree.
Yep.
This is one of the most debatable topics in the security field. It can go both ways. It was mentioned in the Cyber Hackers book. Do you need a degree at all to work in the cybersecurity field? And the answer is, as of right now, I argue no. Here's why. Right now, there's a huge hiring problem. Everyone wants to have the following expertise. You have a CISSP, you have 20 years experience, you have a master's degree or a PhD, you name it, the list goes on. People fail to understand that most schools still don't even teach security. I mean, there you go. There's my argument right there. Most schools don't even teach security. So like right there, you have to ask yourself, like, what's the point? Like, really? I mean, people are very lucky. You should all be lucky to actually have someone like Sam, because honestly, it's still very rare out there for schools to teach security. I'm sorry.
Yep. So they
Um,
just require it because you can't get it.
No. Chris Eng, who's at Veracode. He's the VP of research at Veracode here in Boston. He said to even me, there's a couple of people on his team that don't even have a college degree.
But I think a lot of them do like to see a 4-year degree of some kind. It's a good thing.
It's a good thing if you, well, here's what it does buy you. Here's what it does buy you. There are some schools that are more trustworthy than others. I'll just say that. I'll give you a perfect example. If you come out of a Sam Bone course, if you come out of Carnegie Mellon, I know exactly what you did. So there's credibility right there from who you come out of school with. Also, if you come out of a school like the University of Wisconsin, okay, I can buy that. The reason is I know that they have a very strong systems program. So you know how things, you have a good understanding. You should have a good understanding of how things work. Last but not least, people. You know, there are some schools that have a just really, really good network of people. That's what really helps.
Yeah.
So where a college degree really helps, the foundational stuff and the networking. Life is about people, not things. Like who you know becomes so important.
Yep.
As of right now, do you need to have one? A college degree to be in cybersecurity? No, not yet. It's no different almost than asking, do you need to have the CISSP? Depends what you want to do. You need it? Very debatable topic. It's a good question. Anything else?
Yeah, looks like that's it.
Thank you.
Yeah, thank you very much. Yeah. All right.
Thanks a lot. Thanks for having me.
Yeah, we're really glad we had you. I'm going to end the meeting. I'm going to put it on.
Actually, the opposite is true.
I'm going to put it on the share.
I was going to say,
Thanks.
the opposite.
You're going to make this publicly available?
Yeah, yeah. And I'll tweet it out. You'll see it.
Thank you. Thank you.
Thank you for coming.
Have a good night.
Okay. Bye-bye.
Bye.
Good.
Thanks all.